Hi everybody. We are going to be doing section 2.8 at home this week. So I made a little video for you to be able to fill in your notes so that hopefully that helps make it a little easier for you to think about this. In your book, if you're trying to find more examples, you would want to turn to chapter 2, section 8. The examples that we'll do on this page will have the same number. So this says example 1. You can find more examples like that in your book under example 1. I didn't use the same ones from the book, so you can have all these examples and all the examples in the book. If you need more, you might not need more. Let's first start by talking about the slope of a line. Now you guys did this in Algebra 1, and in pre-algebra you did it too. So this is more something that you've done before, not gonna feel really crazy hard or off the normal trail. N is the letter that we use when we talk about slope. And the formula that has been on the board in the classroom is y2 minus y1 over x2 minus x1. That's the official way that we think about slope when we do it algebraically. Let's talk about what that means though. What we're actually finding when we do that is the change in y. That's the little delta sign. It means the change in y over the change in x. So how far, if you have your 2 points, how far does the x change and how far does the y change? That's how we find slope. That's what it is. What's the difference to get to the x value from each of those points and the difference in the y value? So we can even write that, the change in y over the change in x. And the last one that I'll have you put on there, this might be the easiest when you're looking at a graph. You want to figure out what is the rise over the run. So how far does it go up or down? And how far does it go side to side? Okay, so let's look at a couple of graphs and apply what we know here. To find the slope of each line, let's try one where we just look at the rise over the run. The point is -3.7 and -1.1. So first we'll look at the rise part. Does it go up or does it go down? It actually is going down. That means it will be a negative rise. Let's count how many. 1, 2, 3, 4, 5, 6, 7, 8. So it went down 8, -8. That's our rise. And then we'll see how far it runs. And it's running forward. We do it like we're reading. So as it moves to the right, we call that positive. 1, 2. Runs 2. Positive 2. So -8/2 is the same as -4. That is our slope for that first one. And we did it by using the graph and rise over run. B. We could do the same thing because they gave us a graph, but they won't always give us a graph. So let's try using the formula for this one, y2 minus y1 over x2 minus x1. And we'll just label this point x2, and we'll call this point x1. Or not x2, y2, and this is x1, y1. So this is our point 2. That means our x is a 2 and our y is a 2, and this will be our point 1. So it'll be x1, y1. And let's plug them in then. y2 is 2 minus y1 is a -5. So we get that negative subtracting a negative, which I'm sure it means that becomes add. That's a positive. Over. And we'll take our x2, 6, and subtract our x1, -2. All right, so 2 plus 5, that is 3. Wait a second, 2 plus 5 is 7. Don't listen to me. Okay. And then 6 plus 2 is 8. So this time we got a slope of 7/8. And we used the formula for that. Now, you could check yourself real quick by counting. Does it rise 7 and run 8? Didn't go down, so it would be a positive 7 and it would be a positive 8. Okay, C, this one is a special case, so we want to look at this. There's 2 special cases here. We want to look at both of those so that you can recognize them when you see them. As far as the slope, how far does this line rise from this point to this point? It doesn't, right? So we would say 0. It's rising 0. How far does it run? Well, let's look. 1, 2, 3, 4, 5, 6, 7. It runs 8. But if I have 0/8, what do I have? That's just 0. So we call that slope a 0 when it's not rising at all. It's just a flat line. That's a slope of 0. And I wanted to talk to you about the equation for that line also, because we're also looking at equations today. We would just call this y equals, and then we look to see all the y's in these points are -1. And that's where the line is. It's where y is -1. X's don't matter. I could say if x is 6, what's y? Well, it's -1. If x is 2, what's y? -1. If x is -2, what's y? So all across that line, the y's are -1. And that's why when we write the equation, we don't even mention x. It doesn't matter. Whatever x is, y is -1. All right, let's look at this other special case, D. This line is straight up and down. So still there's not really a slope to it. Let's see, the rise on the top, right? And it goes up 1, 2, 3, 4, 5, 6, 7. And then the run, it doesn't run at all. So that's a 0, 7/0. And if we're dividing 0 by a number, so I've got 7 pennies and I'm taking 0 out. I'm dividing it by 0. Take 0 out, take 0 out, take 0. Those 7 pennies are going to be in my hand forever. That doesn't really make sense. We call that undefined. It can't ever really happen. There's not like a finish to that problem. So it is undefined. And then let's talk about the equation so you're familiar with that. This one, x is always 0. That's because it's right on that 0. If it was over here, it'd be a different number. But x is always 0. And the y's change. The y's can be anything. So x is 0. Y's can be anything. Y doesn't even matter. That's how we would write this equation. The y doesn't even factor into it. So think about those two special cases for their slope and also for how we would write the equation. All right, we've got another one here that we want to try. This is just the points. We don't have a graph. So we'll need to kick in our y2 minus y1 over x2 minus x1. And let's just call this point 1 and this one point 2, which means this is x1, y1, x2, y2. And we'll plug them in. Okay, that was our y2 minus y1. And now we do x2 minus x1. All right, -2 plus 3 is 1. And -6 minus 8 more is -14. So the slope on this is a pretty interesting 1/14, rise 1 and then run backwards 14. Okay, all right, got one here for you to try. Pause the video, use these 2 points and find the slope of the line that connects them. All right, let's check your work on that one. -5 minus -2, -3 minus 6. Now, could you label this one 0.2 and this one 0.1? You could. Your numbers would be flipped, but we would get the exact same answer. So -5 plus 2 is -3. -3 minus 6 is -9. So I know when there's a negative on the top and the bottom that it becomes a positive number. And there's 1/3. So 1/3 should be the answer that you got on that one. Okay, let's move on to equations. That's slope line equations. So there are 2 that we're going to look at for this section. The first one is slope intercept form. And you'll remember this. This sounds familiar. y equals mx plus b, where b is the intercept, the y-intercept, and then m is the slope. So if you are given the slope and the y-intercept, this one is perfect. You just plug them in. The other one we want to look at is point slope form. That is y minus y1 equals m times x minus x1. All right, and we already talked about what slope is. There's our slope right there. And notice it says point slope. So if you're given a point, the point would have an x and a y. That's where these x1 and y1 come in. They're from your point. So we would say the x coordinate that you're given, and y1 would be the y coordinate that you're given. So you've got the point that you plug into these two spots, the slope, and then these guys stay the same. It's just going to be x and y, and they become part of the equation that you're writing. All right, let's try this. Write the equation of the line with slope of 6 and y-intercept of 3. So they gave us a slope and they gave us a y-intercept. Which of those two equations would you think would be the best one? Yeah, I think the slope-intercept form is perfect for this. They told us m is 6 and they told us b is -3. Y equals 6, we're putting it right in there. That's our slope. X plus b is -3. So I'm actually going to change that plus to a -3. And that's it. That's how easy that is when they give you the slope and the y-intercept. Very nice. Okay. Problem is they don't always give us the slope and the y-intercept. So let's try this next one. This is more like the problem that we would have to do some math. That's why there's a bigger space right here. We'll figure this out together. It says write an equation in slope-intercept form. So we have to get it to that y equals mx plus b form for the line that has a slope of 1/5 and passes through the point 5, -2, and then graph the line. So this time they gave us a slope and a point. That means we want to look back up there. I'm going to slide my paper back up, and we need to use the point slope form. That's what they gave us. So we'll plug in these pieces, and then we'll turn it into slope intercept form to finish what they've asked us to do. All right, so we need to have a y coordinate, a slope, and an x coordinate. Let's go back down. Y minus, the y coordinate is this guy right here, right? It's always xy. Y minus -2 equals the slope, which is 1/5, times x minus, and now we plug in the x coordinate, which is 5. All right, that looks really good. We want to simplify it so that we can make it look like this kind of equation, a y equals mx plus b. So let's start on this side. Y minus -2 is really y plus 2. All right, and then notice in slope-intercept form, y is all by itself. So we need to get this 2 moved to the other side. And remember, there's like a line here. Anything I do on one side of an equation, I have to do the exact same thing to the other side. So if I subtract 2 on this side, then I need to subtract 2 on the other side. That keeps it equal. So y equals 1/5 x minus 5, and then I just put that -2 out there as well. Okay, we're looking closer to the slope intercept, but not quite there. We still have this weird, this doesn't match. So distribution, we want to distribute, multiply 1/5 times x, multiply 1/5 times -5. Y equals 1/5 x, and then You are welcome to use a calculator if you want to. This question says 1/5 times -5. So what is 1/5 of 5? If I divide 5 into 5 equal parts, it's just going to be 1. You can get out a calculator if you need to. Sometimes fractions are a little scary. Go ahead. Okay, so we simplified that. And now it looks a little bit more like what we need it to, but these two numbers at the end, let's combine those. So collect our like terms back there. 1/5 x, and then -1 -2, so -3. That looks beautiful. That's what we need to be able to do. Take that point and slope and plug in our pieces, rearrange it until it turns into slope-intercept form. All right, the last part of that question says, then graph the line. And we need to talk about that anyway. When we graph a line from this slope-intercept form, they've given us a y-intercept right here, and then they gave us a slope. So you always start with your y-intercept. There's the y line. It crosses at -3. So on -3, we'll make our first point for this line. Okay. Then from that point, we use the slope, which is 1/5. Rise 1, run 5. Rise 1, run 5. And that's where we draw the second point on that line. So you start with your y-intercept, and then use your slope to find a second point. And then you can sketch that in. If you have a ruler and you like to make nice straight lines, definitely do that. Okay. So we took our point, our slope, turned it into slope-intercept, graphed it. Let's turn the paper over. And I've got one for you to try. Pause your video, and your point should say -10, 8. Go ahead and draw, or find the slope of that line and then draw it. Pause and come back. All right, let's check. So we've got y minus 8 equals -3/5 times x minus -10. Okay, that should be your setup. I think I'm going to simplify this first. X plus 10 minus a negative. Then I'll move my 8. Y equals -3/5 x plus 10 plus 8. Okay, distribute next. -3/5 of 10 is 6 plus 8. Oh, so close. I just need these last two numbers. So y equals -3/5 x plus 2. That should be the equation that you have for that one. Then to graph it, we'll put a point at 2. That's our y-intercept, +2. And our slope is -3/5. So down 3 and over 5. The rise is -3, and we run 5. Okay, I'm going to twist my paper and just kind of sketch that in there. That is what your line should look like. All right, hopefully you got that. If not, take a few seconds, look through and see where you went wrong and fix it. All right, parallel and perpendicular. Parallel lines have the same slope. Same slope. So what does that look like? If I had a line and another line that's parallel, then we should be able to tell for sure by looking at their equations that they are parallel. Let's say the slope of this line is 1/3. And the slope of this line is 1/3. Then I know for sure I'm looking at parallel lines. Those slopes have to match. So if we had equations, if this equation was 1/3 x, we'll say +4, and I'm just making up a y-intercept. And then this equation was 1/3 x plus 1. Okay, so I've got two equations. this is what I look at right here. Do those slopes match? Are they exactly the same? Yes, then I know I'm looking at two parallel lines. I don't even need a graph. I'm just comparing their slope. All right, next, perpendicular. Lines have opposite reciprocal. Opposite, that means positive, negative. If the original slope is positive, then the opposite would be negative. If the original is negative, the opposite would be positive. So the sign has to change. And then reciprocal means that the numerator and the denominator will switch spots. So if it's A over B, the new one has to be B over A. That's not an equal, don't want an equal sign there. It goes to. So reciprocal, they have to switch and the sign has to change. Let's look at what that would look like. If I have perpendicular line, and I'll draw a little 90-degree symbol there to show that I'm saying these two lines are perpendicular. Then if this slope is 1/3, the perpendicular line, since that's positive, the perpendicular line has to be negative. First of all, that sign has to change. And then I have to switch what's on the top and what's on the bottom. So 3 goes to the top, 1 goes to the bottom. And another way we could just write that is just -3. If there's a 1 on the bottom, then we know that it could just be written as -3. That is our slope for that one and our slope. Those are opposite reciprocals. Okay, and if we're looking at an equation, if I had a line that was 1/3 x, we'll just pretend it's the same as that one above, +4, and I'm given another line okay, I can tell for sure by looking at these two equations that these lines are perpendicular right there. 1/3 and -3 are opposite reciprocals. So don't even need a graph to look at. I'm 100% sure those two lines are perpendicular. All right, let's try this then. Let's try to decide if something is parallel, perpendicular, or neither. It says determine whether FG and HJ are parallel, perpendicular, and neither, and then graph the lines. All right, FG, let's start with him. FG. So these two guys are one line, and we're finding the slope, x2 or y2 minus y1 over x2 minus x1. We'll make this point 2, -1 minus, and that can be our point 1, over x2 minus x1. Okay, so let's go ahead and simplify that. -1, and then minus a negative means plus. So -1 plus 3 is 2, and -2 minus 1 more is -3. So we've got -2/3 slope for that line FG. Let's see the other one then, HJ. And we'll do the same thing. y2 minus y1 over x2 minus x1. So we're just taking the x's and the y's and putting them in their spot. 3 minus 0 is 3. 6 minus 5 is 1. So that is the slope of AJ. Or HJ. I'm AJ. HJ. All right, so we have to stop and say, well, first of all, they are opposite signs. This guy's negative and this one's positive. So we've got that part. Are they, first of all, are they parallel? Do they match exactly? No, we rule that one out immediately. Those do not match. And then we look at perpendicular. One's positive, one's negative. Are they reciprocals though? Did the 2/3 flip over and become, would be 3 over 2? Well, the 3 moved, but the 2 and the 1 don't match. So it's not perpendicular either. That means this is neither. Not parallel, not perpendicular. Just two random lines. Okay, let's graph them. So what we can do is, because they've given us 2 points, we'll graph the 2 points. We don't have an equation for a line, so we won't do our y-intercept. We'll graph our 2 points. This is a point at 1, -3. So x is 1, y is -3. We'll put a point there. And the other is -2, x is -2, and -1. And we can draw that. Looks like that. All right. And then our second line is a point at 5, 0. So x is 5, y is 0. There's a point. And then 6, 3. 6, I'm sorry, I didn't make that graph big enough. 6, 3 is about right there. We went right off. We'll draw that in. And I can tell that they're not forming a right angle. They're a little bit closer together. So that matches what we found with our slopes. The two jive. They look good together. All right, let's do another one. I want you guys to try this one. Pause your video and check the slopes to see if they are parallel, perpendicular, or neither. All right, let's see. FG, so this line between those 2 points, -3 minus 2, 6 minus 4, -5 over 2 is a slope that I get for FG. Let's try HJ. 10 minus 5, -3 minus a -1. So 10 minus 5 is 5. -3 plus 1 is -2. So I have a -5 halves and a -5 halves. That negative, there's just one out in the front. So it doesn't matter if it's written on the top or the bottom. They both have a slope of -5 halves. So what is it when they match exactly? Parallel. We have parallel lines. Let's draw them. The F is at 4, 2. Oh, you know, this goes up to 10. So I'm going to make my scale on this one. Each line will be worth 2. So over 4 and up 2, I would look like this. Over to 6 and down to -3. That is my first line. And then -1, 5. Actually, I didn't do that quite right. -1 would be halfway, 5 would be here. And then -3, 10 there. All right, those look like they could definitely be parallel lines. I agree with what we found. Okay, you guys, you are at home. You can work on the assignment for 2-8. This is 2-8. And then when we were in class this week, we worked on 2-7 together. You can upload those assignments to Canvas. You can email me if you're having trouble with that, or you can bring your assignment pages to class next week and we will check them there. Keep your note pages. We are going to start turning those in for points. So this page that we just did, if you turn it in fully filled out, you will get points for it. All right, see you guys later. Bye.